A sluice gate used in water pipelines consists of a gate raised by the spindle, which is operated by the hand wheel of radius 300 mm. The spindle has single start square threads. The nominal diameter of the spindle is 36 mm and pitch is 6 mm. The friction collar has inner and outer diameter 32 mm and 50 mm respectively. The coefficient of friction at the threads and at the collar are 0.12 and 0.18 respectively. The weight of the gate is 7.5 kN and the frictional resistance to open the valve due to water pressure is 2.75 kN. Using uniform wear theory, determine the torque required to raise the gate, force to be applied on the hand wheel to raise the gate, and the overall efficiency. Now, as per the statement of the problem, okay, radius of the hand wheel on which the force is being applied is equal to 300 mm. Then it is a single start square thread, that means lead is equal to pitch. Then W of gate is given, that is 7.5 kilonewton. Then the frictional force required to open the valve is 2.75 kilonewton. That means this is the load of the gate, okay, and this is the friction force required to open the gate, that means to lift the gate. That means W for the lifting of gate will be equal to W of gate plus W of friction. Okay, therefore that value will be 7.5 plus 2.75 kilonewton. Then W of lift will be equal to W of gate. By using a calculator, W of gate will be equal to 10.25 kilonewton. 10.25 kilonewton. Similarly, W for the lowering of the gate, as frictional resistance will resist for the raising of the load, therefore it will be equal to W for gate minus W for the friction. Therefore it will be equal to 7.5 minus 2.75 kilonewton. That's value for W for lower. Calculate by using a calculator. W for the lift, that will be equal to 4.75 kilonewton. Secondly, they have given us the different diameters. Okay, they have given a nominal diameter that is 36 mm, pitch is equal to 6 mm, d naught is given, di is given. Therefore, we can solve this, we can find out the mean diameter. Now these are the parameters that we want to find. Okay, now we want to use this entire data. Therefore dm is equal to, okay, d minus p by 2, d minus p by 2. Therefore 36 minus 6 divided by 2, that will be equal to 33 mm. Second one, that is we want to find out the pitch. Pitch is already given, that is the 6 mm. Therefore we can find out a lead. Lead is equal to pitch, because it is a single start, therefore equal to 6 mm. Therefore tan alpha will be equal to lead divided by pi dm. Therefore 6 divided by pi into dm. Dm we have calculated, that is 36. Therefore tan alpha, calculate 6 divided by pi into 33. That value will be equal to, directly we can find out the value of alpha. Therefore alpha will be equal to tan inverse of 6 divided by pi into 33. That value comes to be 3.31 degrees. 3.331 degrees. Then second one, with mu, we know that the mu of thread is equal to tan of phi. Therefore this will give phi will be equal to tan inverse of mu. Therefore tan inverse of mu of thread, that is 0.12. Therefore phi will be equal to 6.8428 degrees. 6.8428 degrees. Then once we have found, now we want to find out the T total lift. Now we have evaluated all these answers. Okay, now we will use the formula, that is T lift is equal to W into dm divided by 2 into tan of phi plus alpha. Now W for the lift, that means 10.25 into 10 raised to 3. dm is 33 divided by 2 into tan of phi 6.8428 plus alpha 3.31 degrees. Find out T lift. Finally, after calculation, you will get T lift is equal to 30.293 into 10 raised to 3 Newton mm. Okay. Then second one. We want to calculate the collar friction torque. Now they have given that is uniform wear theory to be used for the collar friction. Therefore we can use the formula of the uniform wear theory for the evaluation of the collar friction, that is TC is equal to mu C into W divided by 4 into D naught plus DI. Therefore mu of collar is equal to 0.18. Torque required to lift the load is equal to 10.25 into 10 raised to 3 divided by 4 into D naught 50 plus 32. 50 plus 32. Evaluate the collar friction. Collar friction will be 37.822. 37.822. It is into 10 raised to 3 Newton mm. Into 10 raised to 3 Newton mm. Now lastly we need to find that is total torque, T total. Therefore T total lift will be equal to T lift plus collar friction. Now T lift is equal to 30.293 into 10 raised to 3 plus 37.822 into 10 raised to 3. Therefore T total lift is equal to 68.116 into 10 raised to 3 Newton mm. This is the T total lift. This is the first answer that we want to evaluate. Then the second one, we want to evaluate the torque required to lower the load. The torque required to lower the load, this will become negative. Tan alpha minus, this will become negative. Only this value will get changed because the torque required to lower the load is 4.75 kilonewton. From this, evaluate the answer. From this, evaluate the answer for lowering of the load. You will get answer 4835. Your answer will be 4835 4835.5 Newton mm. 0.5 Newton mm. Then evaluate the collar friction torque. Here also your load value will get changed. That is 4.75 into 10 raised to 3. The value will get changed. That value will be equal to 17.52 into 10 raised to 3. Then we will get, this is the T lower actual, this is the T lower. Therefore T total lower is equal to T lower plus collar friction torque. Therefore you will get the value 4835.5 plus 17.52 into 10 raised to 3. Therefore T total lower is equal to 22.36 into 10 raised to 3 Newton mm. Now you got the value for T lift as well as T total lower. Now we need to evaluate the force required at the end of hand wheel having the radius of 300 mm. Now force required at the end of hand wheel will be evaluated equal to T total lift divided by radius of hand wheel. Okay, therefore T total lift is equal to 68.116 into 10 raised to 3 divided by radius of hand wheel, that is force required at the end of hand wheel to lift the load. Calculate this one. 227.05 Newton amount of force is required to lift the load. Similarly, radius force at the end of hand wheel to lower the load is equal to T total lower divided by radius of hand wheel. Therefore that value will be equal to 22.36 into 10 raised to 3 divided by 300. Therefore T lower to lower the load will be equal to 74.54 Newton. 74.54 Newton. This is entirely regarding the solution of numerical. Thank you.